Hello, my name is Tom Quinn. I'm the founder and CEO of eFuel Corporation, located in Austin, Texas. And also, we have a facility in Paso Robles, California. For those of you that remember where we started from, our roots come from California. Well, I'm here today, and I appreciate the invite to speak with all the university professors and students about this, what I call a breakthrough technology that's going to change the energy and change the world that we live in. And I think it deserves a lot of attention from you folks. And I appreciate UC Davis giving us the opportunity to connect with you folks throughout Japan and the universities that are there. And we hope to be able to answer your questions in the future as well. So let me get with it. We just recently, last month, introduced a product which you can see on our website, which is www.efuel100.com, spelled EFUEL 100.com. And you can find all the information in the background, but I'm going to be walking everybody through today. And I encourage you to do that because I think you need to absorb this information. It's very important. It will change the world substantially, in my belief. My personal background, I'm best remembered for a patent technology called the inertia graphics control system. Everybody in the world, especially in Japan, knows this. The first license went out to Nintendo to make their Wii product, which is the handheld device that gamers used. Eventually, this ended up in all the smartphones used for automobile navigation and other types of products where it actually translates a rotational movement of anything into linear movement on a graphical screen. And that became worldwide. It's very popular. So I know what it is to create something, an invention, which is I'm the sole patent on that technology and what it can do for society. And this one is going to be one of my most important, inventions that I've ever released. And I've been working on this for 12 years, since 2008. And it's very important to me because it stops climate change, period. It's going to reverse this climate change very rapidly and change the way prices for energy are going to plummet down, and the carbon and greenhouse gas are going to plummet down, and there are going to be some changes on the planet. And number one is to fight what we call energy poverty. Energy poverty is when the cost of our energy that everybody relies on goes up in cost, and then affects our ability to pay our rent, our homeowner, payments, our food, medicals, all that stuff is affected because the cost of energy is rising. Why is it rising? Well, it's because we're strip mining this planet, to be direct, of abiotic materials, and it's accelerating, and this is what's causing our climate change. So when I went through my research, of course, I saw the climate temperatures that have been reported for the last 12, 13 years, and they've been measured in amounts that are 0.001 percent per every 100 years or so. And but those really were the effects. They weren't the cause. Now everybody says, "Oh, it's oil," and yeah, that's right. There's oil because oil has carbon in it, and it certainly is the number one factor for it. But there are other things that we strip from our planet that are the same as oil, and I'm going to get into that with this technology. So let's talk about first, what does the term rejected energy mean? Well, this report I got in 2008 from a local, it's the Lawrence Livermore Laboratory in California, not too far from where I grew up. And they took the data for the past 27 years from the US Department of Energy on consumption of power in the United States. And when I started looking at it, it was 63.9% was categorized as rejected energy. Well, what does that mean? Well, that means that, I'll give you an example. If you have a combustion engine vehicle and it's got an empty tank, you fill 3 gallons of fuel into that tank, and then you get in the car and you drive until those 3 gallons have been consumed. Well, what happened is scientifically, due to the inefficiencies, is that 1 gallon was used out of that three to create mechanical energy that was used to rotate the wheels of the car. The other 2 gallons were released out of the tailpipe, out of the radiator as form of heat, and the tailpipe as gas, and friction heat of the engine. So really what happened is we only use one out of those 3 gallons of fuel, to mechanical energy to move ourselves. And the rest went into our atmosphere. Well, what does that mean? Well, I mean, we dug into the planet to get those 3 gallons of fuel to provide for energy needs. And we wasted 2/3 of that. And it's getting worse. It's approaching 70% now. So that's what it is. Now, if you think it's just automobiles, it's everything that we manufacture in the world. We're strip mining for it. And let's take batteries. Batteries reject energy all the time. And we know that from our smartphones. When you buy a new smartphone, it's the battery lasts for some 3 days, and then as it ages within a few years, it's less than a day. And when it ages, it's rejecting energy because the cells of the battery are being damaged and deteriorating, and it can no longer store the density of energy that it once had. And this happens with all batteries, regardless of what kind of technology you're using. And so we're discarding energy in an enormous of amount, and we're not using it to better our lives. We're using most of the energy to destroy our living things on Earth. I mean, it's, when you get into this and you wrap your head around it, it's shameful. It's unbelievable what we've done. Now, this all started, I say, 138 years ago when Thomas Edison, the inventor in the United States, built a power plant that ran on coal back in the 138 years ago in the 1800s. He flipped the switch in Manhattan Financial District and powered the streetlights out of there using coal. And we have on our website, which you can see, and we'll show you hopefully on this video, that photo, or it's actually a painting of the Edison plant spewing out hot gases out of the plant. Now, just imagine that time period when, if you were there, you enjoyed the fresh air and everything around that Manhattan area. And all of a sudden, Thomas Edison flips a switch and he's providing us power, which there's no doubt that helped humanity advance. There's no question about it, okay? But it changed everybody's world in that area because they were now breathing in, greenhouse gases, carbon, everything else. It's changed. It dirtied the buildings, the windows, everything around there is being affected. Not only humans, but animals, everybody got affected by that. Well, now advance yourself 138 years later, and it's worse than ever, So, but let's get on with that. So, what I want to tell you right now, okay, so I started thinking about what do we do about this? Well, we're going to have to capture this rejected energy, and we have to utilize it because we're talking about, and by the way, this rejected energy does not include the transportation industry or the aviation industry. It only includes the power industry. And most of that 27 years was just the retail power industry, but they added in 2017 the manufacturing part of power industry that now shows us that it's getting worse and worse and worse. All right, but we have two other major industries we haven't reported. So I mean, and this is only the United States. I mean, this thing I mean, can be well over 100%. If we really get together in the world and figure it out, I'm not sure anybody wants to know this thing. It's the news is just it's terrible. All right, but let's get back to what's the solution? That's very important. Now, how do we do this? So, uh, I've been an inventor for many years. I've been in a lot of things in my lifetime, in my career, and this one actually is not the hardest one I've ever had to challenge. Actually, it was is the I would say the gyroscope was one of the hardest thing to do for the inertia sensing system. But this one, what we did is we created a reactor, a special reactor. And over the 12 years, the eFuel Corporation invented what we call a microfueler technology. What is that? Well, if you look at fuel columns, how they produce fuels. These things go up to 300 feet tall and 10 feet wide or so, and you heat them with energy to create a vapor that separates the solids of the crude oil or the ethanol beer to make organic ethanol, or in that case oil-based gasoline, diesel, and all that other stuff. All right, so we've shrunk that down to about 6 feet. I mean, substantially. And I can't get into the IP side of it, but we've now been able to make a very small, compact fuel plant that can, take over from a 300-foot, a distillation column and make it completely portable. The same volume capacities. So it's a game changer. The second thing that we did was we invented a power generating source that allows us and small enough so we can take that power source that's fed with fuel and put it inside the reactor. So now in the chamber of the reactor, we have a fuel processing plant and a power processing plant all together. So now when those 3 gallons are primed into the a reactor, to start the reactor, all 3 gallons are contained within the reactor. 1 gallon now is moving from mechanical energy, and the other 2 gallons are there to process fuel. So you have this, ability to create fuel at zero cost for the power plant. I mean, I think that is just amazing what this accomplishment is. It's almost like perpetual energy, which of course it's not, but it's driving down the cost of that energy substantially. It's a game changer. Okay, so what happens now is we have the ability to use those other 2 gallons, even more, to create electrical power. And so what can we do with that electrical power is we can do 2 things, or the reactor, I should say. Let me broaden that a little bit. Of course, we can create power. Now, we've decided we're not going to move into the production of fuels for diesel or gasoline. We're going to, abandon those. And what we're going to do is we're going to focus on organic fuels, which is ethanol. Now, ethanol today is normally made with abiotic fuels. I mean, you can't consider it an organic fuel because the process mode is made with abiotic fuels. So we're going to change that, and we're going to make it with organic, pure organic. There won't be any abiotics in here. And the other thing we need to identify is that this fuel is carbon negative. All right, so the definition of a carbon negative is the fact that we have captured the carbon in greenhouse gases before they've gotten out, and we've stored them in a liquid, and that liquid is going to be a product that we're going to sell to agriculturals, especially greenhouse plant growing shelters and stuff like that to grow. This is an advance. This is very important because everybody knows that plants consume carbon, and now we're going to be selling a liquid, which is like food to us. It's going to be food for the plant, and this could be in portable mode, so it could go anywhere around the world and help farmers accelerate the growth. And this will accelerate the growth of our agricultural departments or farming substantially. Carbon makes them grow faster. Okay, and I won't get too much into that, but actually I learned that from UC Davis. They've done a good job, as many have done around the world. But in particular, I got my education there from UC Davis, which just through visiting them, and they showed us how they were able to achieve that. So this is a big benefit. So carbon negative, everything we're going to do. So the next thing we do is we have ethanol, we have power, unlimited. The reactor can make anywhere from kilowatts to gigawatts. We've created an energy cage, just like a cloud company like Google that has all their data stored on file servers, which, by the way, was a former company, Novell, that I was president of. We worked on the original cloud storage type of server base on a PC. I wanted to throw that one out. But anyway, that's where I got my idea to develop these energy cages. So the reactor is very small in size. It would be 10 feet in length and about 5 feet in width and about 7 feet on the height side of it. But these are on rollers. They can be rolled into energy cages just like file servers. And they're very intelligent. They can be daisy chained. So if you want kilowatts to gigawatts, no problem. And because there are redundancy in these energy modules, they also have the ability to have an incredible, reliable, fault-tolerant environment where you're not going to find power going out or fuel not being able to produce anymore, because these little miniature modules, in the energy field, they're quite small. They'll be able to provide extreme reliability. Now, before I go on, where we're going to do that is, let me explain the other couple of fuels. The other fuel we're going to do is hydrogen. Now, hydrogen, if you're familiar with it, it has some obstacles to make mainstream. They're getting closer. But one of the major obstacles of hydrogen is the cost of hydrogen. It's very expensive because it's done with an electrolysis process, meaning that the electrical power arcs inside with the ability and the catalyst of that hydrogen system to create the hydrogen gases on that. And our process is pretty much almost free. So now people that have been trying to get hydrogen for affordable cost that isn't going to be 3 times the cost of our fuel now, they're going to be in the game now to be able to compete on cost wise. And since it's portable, we can make hydrogen on demand at any fueling station in the world. And we can get into that in more detail at a later time. But hydrogen, one of the negatives was it's got 3 to 5 times the energy density of other fuels, and that's very concerning to have a large supply on any plant. But we're making fuel as we're consuming it, so the danger of hydrogen has really been eliminated. And people ask me, well, can we adapt this to other technology like vehicles? Absolutely. We're just getting started on this thing. This is going to be a $5 trillion plus market. We can adapt our technology to all sorts, aviation, aerospace, you name it. I mean, we're going to change the world with this. So, but I've been digressing because you can tell I'm pretty excited about this. So on the last side of it is we're going to do an oil-based fuel, which is also carbon negative because it goes through the same process, but we're going to create a kerosene jet fuel. That's important to use oil because the kerosene is most compatible and safe to run a jet, turbine. And a lot of people have experimented with different types of renewable. They call it renewable, but it's really not renewable. Energy type things that we have. But we'll make this the first carbon negative jet fuel in the world, and it will be substantially less, and it'll be made at airports in a safe manner where you're not going to have large storage there, because it makes like kind of an ice cube maker. Once you take some ice in that cup, it starts making more ice. Well, once you fill a jet up, it's going to make more hydrogen, or excuse me, in this case, more kerosene jet fuel. So this is the way it's going to be changing. I know everybody will have a lot of questions, and I know I'm going to come back at a later date and field some of your questions. But let's move on from there. So now you know the basis of what we can do with this e-fuel energy reactor. It's going to be a game changer, that's for sure. So how do we get this into the market? Well, we're going to create a partnership internationally, and we're reaching out to energy companies first, because this will destabilize the energy industry. There's no doubt about it. And anybody that technology has consequences, and this consequence, who gets hurt? Well, who's going to get hurt is the oil refinery business. We're going to go from a centralized energy distribution, just like Steve Jobs. He went against the mainframe industry like IBM and digital equipment, and he was thought to be a novelty toy in the beginning. And then he showed where it's much more efficient to have local processing at that level. And same goes for the reactor. The reactor is going to have the ability to make fuel and energy power at your home, or an office building, a community. We'll go in, and it'll change everything from the cost of fuel for freighters on the ocean, the cost of energy for, as you know, aviation, power, everybody. So the refiners are going to get hit pretty bad. I mean, and the production of oil. It's going to be big. I mean, we're talking about up to 70% reduction in oil, across. So that's going to be. But we're inviting these energy companies, and I think is we want to join together with these folks and have a good transition, so we can appreciate it. So eFuel will be the manufacturer, and our partnerships will be the distributors of the products, and they'll also be the delivery of the what we call enhanced ethanol beer and enhanced crude oil. And that's a proprietary blend, but we can't get into that. But there'll be, and trust me, all the distributions are already been set up in the United States and a lot of the world. In the United States, you can ship these products anywhere in the U.S. to any state. There's a national, a lot of people don't know this, but there's a national pipeline of fuel products where you can get it. So this will come very fast, once we adapt this thing for everybody. All right. So, and this will also, and this is very important, you're going to see a decrease in energy poverty, because now people will be able to get more affordable energy for substantially less than they were getting before, and with also jobs. We're gonna take this job like Apple Computer did, and we're going to provide jobs all over the world. So for maintenance and sales and all this other stuff, it gives major opportunities for everybody in the world. What we have been saying since we started, let's make our own energy. That's been our motto, our slogan at eFuel for a long time. So you'll really you'll appreciate that. So that's what we have, and climate change will be solved with this, and we look forward to it. It is going to be one of the largest paradigm shifts in the world. We're going after an energy market which includes renewables. Renewables will also be hit fairly hard with this because they are abiotic extractions from Earth, and I know that's going to cause a disturbance there. But if we want to save this planet, we got to quit stripping this planet like it was a dead planet. I mean it. It's going to take the people and the consumers and the world to stand up now and say enough of stripping our planet and killing thousands, tens of thousands of species of life on this planet have been destroyed over the years. And we don't see that because we're not out there blowing up things to extract the minerals from the planet. And it's an ugly sight, and we're killing the planet. And so I want to emphasize this. So let's be prepared to take this on. It's going to be a large paradigm shift, And the more that we get to sponsor, you can visit our website at, like I said, at efuel100.com, as I mentioned before, and I encourage you to do that. But that's it, guys. So I appreciate the chance to talk to everybody in these universities in Japan, and I hope you learned something from it. And I look forward to hearing your questions, and I'll look forward to answering them as best I can. Thank you very much.